Let us turn our minds away from the green earth and out into the cold, magnificent vacuum of space. There, in the aftermath of a supernova, one of the universe's most violent and brilliant events, a miracle of physics is often left behind. A neutron star, an object of such impossible density that a single sugar cube sized piece of it would weigh as much as a mountain. And some of these cosmic cinders perform a silent, breathtaking ballet. They spin not once per day or once per hour, but hundreds of times every single second. These are the pulsars, the universe's most precise metronomes. Imagine the corpse of a massive star, a sun that has collapsed under its own immense gravity. It has been crushed down into a sphere no wider than a city, yet containing more mass than our own sun. In this collapse, the law of conservation of angular momentum takes over, the same principle that sees an ice skater spin faster as they pull their arms in. As the star shrinks from a millions of kilometers wide giant to a 20-kilometer wide remnant, its spin is accelerated to a rate that defies human comprehension. A newborn pulsar can complete a full rotation in a mere fraction of a second. This is not a gentle turning. This is a whirling dervish of atomic matter, spinning so rapidly that its surface moves at a significant fraction of the speed of light. And as it spins, it beams. Powerful jets of radiation, like the focused ray of a cosmic lighthouse, stream from its magnetic poles. If one of those beams sweeps across the Earth, our telescopes detect it as a perfectly timed pulse of energy, a blink of radio waves, gamma rays, or X-rays that arrives with a predictability more precise than any atomic clock we can build. The consistency of this pulse is profoundly soothing. It is the universe counting out a steady, unfaltering rhythm against the silent dark. There is a deep, humbling peace in this phenomenon. It is a demonstration of the universe's predictable mathematical heart. From the chaotic fury of a stellar death emerges one of the most orderly phenomena known to science. The neutron star does not spin out of frenzy, but as a consequence of immutable physical laws. It is a reminder that even in the most extreme corners of creation, there is balance, there is pattern, and there is a rhythm, a gentle, silent, and impossibly fast heartbeat in the vast, sleeping body of the cosmos. Some black holes emit jets of light across galaxies. Let us contemplate one of the most powerful and serene paradoxes in the cosmos, the supermassive black hole. We often imagine them as the ultimate voids, regions of space-time where gravity is so intense that not even light can escape. Their pull is absolute, their silence profound. And yet, from the very edges of some of these cosmic giants, from the swirling superheated maelstrom of matter that surrounds them, erupts a spectacle of unimaginable beauty. Vast, precise jets of energy and light that can stretch for thousands, even millions of light years, piercing the darkness between galaxies. These are not jets of material escaping from the black hole itself. Nothing can return from beyond that final boundary. Instead, this magnificent display is born from the material just outside the event horizon in a region known as the accretion disk. Here, gas, dust, and even entire stars are pulled into a frantic orbiting dance, heated to temperatures of millions of degrees by friction and immense gravitational forces, glowing with a fierce, radiant light. But not all of this doomed matter falls in. A portion of it, caught in the black hole's immensely powerful magnetic fields, is funneled toward the poles and accelerated to nearly the speed of light. It is then launched into the void in two opposing, exquisitely focused beams. These jets, composed of a storm of subatomic particles and intense radiation, become cosmic lighthouses, their brilliance often outshining the combined light of every star in their home galaxy. There's a profound and soothing elegance to this process. It is a perfect balance of forces, chaos and order, destruction and creation, playing out on a galactic scale. The black hole, the ultimate symbol of consumption, becomes the engine for one of the universe's most brilliant and far reaching displays. These jets travel across unimaginable distances, and in their passage, they can compress interstellar gas, triggering the birth of new stars. They are, in a sense, agents of both end and beginning. To witness such a jet from the safe expanse of intergalactic space would be to see a silent, slow motion fountain of pure energy, a testament to the hidden laws that govern existence. It is a reminder that even from the deepest darkness, light can be born, that the universe contains forces of immense violence that nonetheless produce structures of breathtaking order and grace. The galactic jet is a lullaby of physics, a slow, stately, and silent exhalation of energy that whispers of the beautiful, predictable, and awesome power hidden within the heart of darkness. Dark matter makes up most of the universe, but is invisible. Let us contemplate the greatest and most gentle of all cosmic mysteries. It is a presence that surrounds us, that flows through us, that binds the very galaxy together. It is the dominant substance of the cosmos, the unseen architect of the universe's grand design. And yet, we cannot see it, touch it, or directly perceive it in any way. This is the serene and profound enigma of dark matter. Imagine the spiral arms of our own Milky Way, a vast pinwheel of stars, gas, and dust, spinning gracefully in the void. Based on the visible mass of all these glowing components, the stars on the outer edges should be moving much more slowly, drifting lazily in their orbits. But they do not. They race around the galactic center at velocities that defy the pull of the gravity we can see. It is as if the galaxy is far, far heavier than it appears, embedded within a massive, invisible sphere of something. A something that exerts a powerful gravitational pull, but emits no light, no radio waves, no energy that our most sensitive instruments can detect. This is the evidence for dark matter. It is the ghost in the cosmic machine, the silent partner to all the light and color we observe. Its gravitational whisper is what guides the formation of galaxies and the vast, web-like structure of the universe. We know it is there because we can see what it does, the way it bends the path of light from distant galaxies, the way it holds immense clusters of galaxies together. We are like someone feeling the shape of the wind by watching the dance of leaves. We cannot see the wind itself, but its influence is unmistakable. The true nature of this invisible substance remains one of science's deepest secrets. It is not made of atoms, not of the protons, neutrons, and electrons that constitute every star, every planet, and every one of us. It is something else entirely, a fundamental particle that interacts with our world only through the faintest of touches, the force of gravity. There is a profound comfort in this mystery. Dark matter teaches us humility, reminding us that the universe is composed far more of the unknown than of the known. The familiar, tangible world of matter and light is but a delicate shimmering froth on the surface of a deep, dark, and silent ocean. This hidden architecture does not threaten us. It cradles us. Its immense, gentle gravity holds our galaxy in its embrace, providing the stability that allowed our sun to form and our world to evolve. So dark matter is the universe's ultimate lullaby. It is the quiet, unseen presence that makes the visible world possible. It is the deep and steady hum of gravity in the dark, a reminder that what we perceive is only a fraction of what is real, and that the greatest forces in the cosmos are often the most silent, the most patient, and the most hidden from view. The largest known star is over 1,700 times the Sun's radius. Let us turn our gaze to the constellation of Scutum, and there, nestled in the vastness, contemplate a celestial giant of almost unimaginable scale. A star known as Stephenson 2-18. To speak of its size is to stretch the very limits of our comprehension. This is not merely a star larger than our sun, it is a leviathan so vast that it redefines the word star itself. If we could perform a gentle cosmic swap, placing this star at the center of our own solar system, its surface would extend far beyond the orbit of Saturn. The Sun, Earth, Mars, the asteroid belt, and Jupiter would all be swallowed whole within its luminous, tenuous atmosphere. Our entire planetary system, out to the rings of Saturn, would simply vanish inside its crimson glow. This is a red supergiant, a star in its final magnificent act. It has exhausted the hydrogen fuel in its core and now burns heavier elements, causing its outer layers to expand into a sphere of incredible volume, yet of astonishingly low density. Much of this star is a brilliant, diffuse cloud of hot gas. If you could fly a spaceship through its outer layers, you would be sailing through a glowing, tenuous fog, a sunset that stretches for hundreds of millions of miles. The sheer physical fact of this star brings a profound and humbling sense of peace. Its existence reminds us that our sun, which dictates the rhythms of our days and the growth of our crops, is but a tiny, gentle candle flame in the grand cathedral of the galaxy. The processes that govern such a giant are slow and majestic, playing out over millions of years. Its immense expansion is a predictable, natural phase in the life of a massive star, a final deep breath before it eventually collapses and ends its life in a spectacular supernova, seeding the cosmos with the elements forged in its furnace. So, as you look up at the night sky, remember that hidden in the darkness are such gentle giants. They are not twinkling points of light, but roaring slow-motion infernos of cosmic proportions. Stephenson 2-18 is a lullaby of scale. It whispers to us of the immense range of creation, of the fact that the universe operates on a canvas so large that our minds can scarcely picture it. It is a soothing reminder of our own small, precious place in a cosmos that has room for both our tiny, rocky world and for suns so large they could hold billions of them within their fiery embrace. Cosmic microwave background radiation is left over from the Big Bang. Let us journey back not to a place, but to a time, to the very beginning of everything, to a moment of unimaginable density and heat, the singular event we call the Big Bang. In the first fleeting instance, the universe was a blinding, opaque sea of energy and fundamental particles, too dense for light to travel any meaningful distance. For hundreds of thousands of years, it expanded and cooled until it reached a critical temperature, a point cool enough for electrons and protons to combine into the first atoms. In that moment, a profound transition occurred. The universe, once a foggy plasma, suddenly became transparent, and the light that had been trapped, bouncing between particles for eons, was finally set free. That first light is still with us today. It has been traveling for over 13 billion years, stretching and cooling with the expansion of the universe itself. Its immense energy has been diluted by the vastness of space, its searing heat reduced to a whisper of cold. We now detect it not as visible light, but as a faint, uniform glow of microwave radiation that permeates every cubic inch of the cosmos. This is the cosmic microwave background, or CMB. It is the oldest thing we can ever observe, the faded afterimage of creation, the residual warmth of the universe's birth. If you could see microwave radiation with your eyes, the entire sky in every direction you looked, day and night, would glow with a soft, uniform light. It is the universe's foundational energy, a backdrop upon which every galaxy, star, and planet is painted. This glow is not perfectly smooth. It contains tiny, tiny variations, ripples in temperature that are only a few millionths of a degree. These infinitesimal fluctuations are the seeds of all structure. They are the gravitational wells into which matter would eventually fall, giving rise to the first galaxies and the vast cosmic web we see today. There is a deep, profound comfort in the cosmic microwave background. It is the ultimate lullaby of the cosmos. It is tangible evidence that our universe had a beginning, that it has evolved in a predictable physical way, and that it is, in its very fabric, a single connected entity. This gentle, cold radiation is the final echo of the first great flash, a silent, steady hum that fills the void. It is the universe's oldest memory, a fossil of light that reminds us we live in an expanding, evolving cosmos that began long ago and whose first breath we can still feel all around us as a whisper of primordial heat against the eternal cold of space. Rogue planets drift alone without orbiting a star. Let us turn our minds away from the warm, familiar light of suns and solar systems and out into the profound, silent blackness of interstellar space. Here, in the vast, empty tracks between the stars, a different kind of world exists. Not a planet tethered to the gentle, predictable rhythm of a star's gravity, but a solitary wanderer, a rogue planet. These are worlds that have been cast adrift. Some may have formed alone, like failed stars that never gathered enough mass to ignite. Others were born in the turbulent nurseries of young solar systems, only to be violently flung out by the gravitational pull of their sibling planets, sent careening into the deep, eternal night. Imagine such a world, a frozen dark sphere of rock or gas, untethered from any sun. There is no sunrise here, no dawn, no noon, no dusk. The landscape, if one could see it, would be illuminated only by the faint, cold light of the distant, unmoving stars. The concept of a year has no meaning, for there is no orbit to measure it by. Time is marked only by the planet's own slow, silent rotation. A day that may last for eons, turning one half forever toward the galactic core and the other toward the infinite void. And yet within this absolute exile, there can be a hidden, gentle warmth. Tectonic forces deep in the planet's core, or the radioactive decay of heavy elements in its mantle, could provide enough heat to maintain vast, subsurface oceans of liquid water, sealed beneath a thick crust of ice. In these lightless abyssal seas, entirely independent of any star, the chemistry for life could potentially stir. A biosphere thriving in absolute isolation, unaware that any other worlds exist, living by its own slow geothermal rhythm. The existence of these lone wanderers brings a strange and profound sense of peace. They are a reminder that the galaxy is far more diverse and mysterious than we once imagined. They speak of a cosmos filled with untold billions of these dark, silent nomads, far outnumbering the stars in our sky. They are the ultimate hermits of the galaxy. The journey of a rogue planet is the most serene and solitary voyage imaginable. It is a lullaby of solitude, a celestial body moving to its own silent internal music, on a course that will never bring it close to the warmth of a star. It is a reminder that even in the deepest, coldest dark, there can be a quiet, self-sufficient existence, a world entire unto itself, sailing forever through the silent, sleeping sea of space. Some exoplanets have clouds of molten glass. Of all the beautiful worlds we have discovered orbiting distant suns, Few inspire such a serene and awe-inspiring vision as the exoplanet known as HD 1897333b. This is a world that defies our terrestrial imagination, a place where the very sky is a work of both violence and art. For here, swirling in winds that scream at thousands of miles per hour, are clouds not of water vapor, but of silicate, clouds of molten glittering glass. This planet is a hot Jupiter, a gas giant orbiting so perilously close to its parent star that its year is but a fleeting 2 Earth days. The same minerals that form sand on our beaches are, on this world, vaporized, rising into the atmosphere to condense into countless microscopic droplets of liquid glass. Imagine standing on a hypothetical platform, looking up into a searing alien sky. It would not be blue, but likely a deep, hazy cobalt, the color imparted by the silicate haze. And through this haze, these clouds of molten glass would drift, reflecting the furious light of the nearby star. When the conditions are right, it is believed this glassy rain would fall, but it would not be a gentle shower. It would be a horizontal scorching tempest, propelled by supersonic winds, a storm of razor-fine, liquid diamonds scouring the landscape. Yet for all its ferocity, there is a profound and calming beauty in this world's predictability. It is a demonstration of the laws of physics and chemistry pushed to an extreme. The universe, in its infinite variety, has crafted a world where the sky itself is a jeweler's furnace. It is a reminder that the familiar elements of our own world, the silicon and oxygen in the rocks beneath our feet, can, under different stars, become the stuff of clouds and rain. HD 1897333b presents a lullaby not of gentle nature, but of cosmic order. It shows us that even the most alien and hostile of environments are not chaotic. They are governed by the same principles that give us our own sunsets and breezes. The existence of a world with glass clouds expands our understanding of what is possible, inviting us to contemplate the serene, silent, and majestic artistry of the cosmos. An artistry that can paint with a palette of molten stone, creating a jeweled sky in the deep, eternal night. Fast radial bursts arrive mysteriously from distant galaxies. Let us turn our attention to one of the most elusive and enchanting melodies in the cosmic symphony, the fast radio burst. From the deep, silent tracks between galaxies, from billions of light years away, comes a signal. It is a burst of radio waves, a brilliant, fleeting note that compresses more energy than our sun emits in 80 years into a mere thousandth of a second. And then, just as suddenly as it arrived, it is gone. These are not the steady, predictable pulses of a spinning neutron star. They are cosmic interjections, profound and random shouts in the dark. Most are heard only once, a solitary, unmatched event that defies repetition. A few, however, are repeaters, sending their mysterious signal out into the void more than once, though never with a pattern we can discern. They are like a distant, celestial lighthouse that flashes only when it chooses to, for reasons known only to itself. The source of these bursts is one of modern astronomy's most captivating puzzles. What cosmic event can be so cataclysmatically powerful and yet so breathtakingly brief? The theories are as elegant as the mystery itself. They could be the final, dying breath of a star being shredded by a black hole, or the immense magnetic shockwave released when two super-dense neutron stars spiral into each other and merge. Some have even pondered whether they could be the focused propulsion beams of unimaginably vast interstellar light sails, though most astronomers find a more natural, yet equally spectacular, explanation to be the most soothing. There is a profound and humbling peace in this mystery. These bursts have traveled for billions of years, across distances so vast they numb the mind, only to arrive at our telescopes as a tiny, almost imperceptible flicker in our data. They remind us that the universe is still wild, still filled with phenomena we do not yet understand. They are the universe reminding us that it still holds profound secrets. The fast radio burst is a lullaby of the unknown. It is a gentle, rhythmic punctuation in the quiet of space, a reminder that even in the deepest silence, there are brief, brilliant flashes of something extraordinary. We may not yet know what creates them, but we can listen to their distant echo, a single perfect note that has crossed the cosmos to tell us, if nothing else, that we are listening, and that the universe is still and always full of wonder. The universe expands faster than light in certain regions. Let us contemplate one of the most serene and mind expanding truths of our cosmos. It is a concept that feels like a gentle paradox, a whisper of the profound laws that govern all of existence. In the vast, dark reaches between galaxies, the very fabric of space itself is stretching, and in certain regions, it is stretching at a rate that carries galaxies away from one another faster than the speed of light. It is crucial to understand this gentle cosmic truth. No object is traveling through space faster than light, which the laws of physics forbid. Instead, imagine the universe as the surface of a slowly inflating balloon. If two ants sit on this balloon, they are not walking away from each other, but the space between them is growing, causing them to drift apart. Now, if the balloon is large enough and inflates quickly enough, two distant ants will be separated at a speed that, if they were moving, would break all rules. This is the nature of our universe's expansion. The engine of this immense, silent journey is what we call dark energy, a gentle but relentless pressure inherent to the vacuum of space itself. It is not an explosive force, but a steady, patient push that works on the very geometry of the cosmos. The more space there is between 2 points, the more new space is created in the gap, and thus, the faster those points appear to recede from one another. For any galaxy beyond a certain immense distance from us, a horizon known as the cosmological event horizon, the accumulated expansion of all the space between us, is carrying it away at a velocity greater than light. This means its light, no matter how bright or how long it shines, will never reach us again. It has passed over a cosmic ridge, vanishing from our future view, not with a cataclysm, but with a silent, inevitable fade. There is a deep and humbling peace in this realization. The universe is not just expanding, it is accelerating in its expansion, guided by a force we can only infer. It creates a soft, fundamental boundary to our observable universe, a horizon of causality. It tells us that much of the cosmos is already lost to us, not because it has vanished, but because the stage upon which it sits is growing faster than any signal can cross it. This is the universe's most gentle and final lullaby. It is the quiet, stately, and inexorable process that ensures vast regions of creation will remain forever mysterious, isolated in their own island universes. It is not a violent tearing apart, but a slow, dignified, drifting into an eternal and silent separation, a reminder that the cosmos operates on a scale and by rules so grand that they inspire not fear, but a profound, awe-filled tranquility. Quasars shine brighter than entire galaxies. Let us turn our minds to the deepest reaches of space and time, to the edges of the observable universe, where we find the most luminous, persistent objects in all of creation, quasars. The name itself means quasi-stellar radio source, for they appear in our telescopes as mere pinpricks of light, like distant stars. But this is a magnificent deception. A single quasar can outshine an entire galaxy of 100 billion stars. This almost unimaginable power does not come from a vast collection of suns, but from a single, terrifying, and beautiful engine, a supermassive black hole. Not a dormant one, but a voracious giant, millions or even billions of times the mass of our sun, sitting at the very heart of a young galaxy. As vast clouds of gas, dust, and even entire stars are pulled into its irresistible gravitational embrace, they do not simply vanish, they spiral inward, forming a searingly hot, frenzied whirlpool of matter known as an accretion disk. Friction within this disk heats it to temperatures of millions of degrees, causing it to glow with a blinding, ferocious light across the entire electromagnetic spectrum. As matter is devoured, some of it is channeled by immense magnetic fields and blasted away from the poles of the black hole in jets of radiation and particles that can stretch for hundreds of thousands of light years. These are lighthouses on a cosmic scale, their beams visible across the universe. There is a profound and soothing paradox here. The most destructive force in nature, a black hole from which not even light can escape, becomes the very source of the most brilliant and enduring light we can see. It is a perfect cycle of cosmic energy, chaos and creation intertwined. The quasar shines so brightly because it is feeding, growing, and in the process, shaping the evolution of its entire host galaxy. The light from the most distant quasars has been traveling for over 10 billion years to reach us. We are witnessing the violent, brilliant youth of the universe, a time when galaxies were being forged. To contemplate a quasar is to witness the raw, fundamental power that built the cosmos. It is a lullaby of immense forces, a reminder that even in the darkest hearts of galaxies, there can be a light that outshines all others, a beacon born from the very act of consumption, a silent, brilliant testament to the dynamic and magnificent cycles of the universe. Saturn's rings may be younger than the dinosaurs. Let us turn our gaze to the jewel of our solar system, the serene and majestic planet Saturn. For centuries, its magnificent rings have been a source of wonder, a symbol of cosmic perfection and timeless beauty. They appear as a delicate, shimmering halo of ice and rock, a vast, flat disk stretching hundreds of thousands of kilometers across, yet in places no thicker than a two-story building. We have long assumed they were as ancient as the planet itself, forming over 4 billion years ago from the primordial dust and ice of the young solar system. But recent observations from spacecraft like Cassini have whispered a startling and beautiful secret. These iconic rings, these perfect celestial bands, may not be ancient at all. In fact, they may be younger than the dinosaurs. The evidence comes from a quiet, constant rain. Saturn's powerful gravity pulls a fine, steady stream of dusty micrometeoroids and water ice particles from the rings inward toward the planet. By carefully measuring the rate of this slow but relentless flow, and by analyzing the surprising purity and brightness of the ring ice, which should have been darkened by cosmic dust over billions of years, scientists have arrived at a humbling conclusion. The rings we see today are likely not primordial. They probably formed within the last few 100 million years, a mere heartbeat in cosmic time. This means that when the mightiest of the dinosaurs, the Tyrannosaurus rex, roamed the earth, the night sky it looked upon may have been missing one of its most glorious features. Saturn, in that distant age, could have been a plain, ringless world. The rings may have blossomed during the age of mammals, perhaps from the catastrophic breakup of an icy moon or a wandering comet that ventured too close and was torn asunder by Saturn's immense gravity. There's a profound and soothing poetry in this. It reminds us that the cosmos is not a static museum, but a living, changing theater. The most seemingly permanent and majestic structures can be fleeting wonders on a galactic timescale. The rings of Saturn are not an eternal fixture. They are a temporary, brilliant performance. They are a celestial bloom that has graced our solar system for only a short while, and one that will, over millions more years, slowly fade away as the gentle rain of ice continues. So when you look at Saturn through a telescope, you're not looking at an ancient relic. You're witnessing a vibrant, dynamic, and surprisingly youthful work of art. It is a lullaby of cosmic impermanence, a gentle reminder that we are living in a special moment in the long life of our solar system, a moment graced by the presence of a ringed giant, a beautiful, fleeting gift from the heavens. Venus spins backward compared to most planets. Let us turn our attention to our celestial neighbor, often called the morning star or the evening star. Venus, shrouded in thick, swirling clouds of sulfuric acid, holds a secret in its slow and solemn rotation. While nearly every other planet in our solar system spins counterclockwise on its axis, as viewed from above the sun's north pole, Venus performs a quiet, solitary dance in reverse. It spins clockwise in what astronomers call a retrograde rotation. This means that on Venus, the sun would not rise in the east and set in the west. If you could stand on its scorching, volcanic surface, you would witness a most peculiar sight. The sun would rise in the west. It would crawl slowly across a hazy orange sky, and then, many Earth months later, set in the east. A single day on Venus, from one sunrise to the next, lasts longer than its entire year. How did this come to be? The solar system is a dance of chaos and gravity, and the prevailing soothing theory is one of a cosmic tap on the shoulder. In its youth, our solar system was a crowded and dynamic place with protoplanets and planetesimals jostling for space. It is likely that in this ancient era, a massive object, perhaps the size of a small planet, collided with Venus in a slow, grazing impact. This was not a cataclysm that shattered the world, but a gentle, gravitational nudge. A cosmic billiard ball that transferred enough angular momentum to slowly reverse the planet's spin, or perhaps tip it completely upside down, resulting in what we now see as a backward rotation. Another, more serene possibility is that the thick, dense atmosphere of Venus, coupled with gravitational tugs from the Sun and other planets over billions of years, created a tidal friction that gradually slowed its original spin to a halt, and then, ever so slowly, began pulling it in the opposite direction. The backward spin of Venus is a lullaby of cosmic patience. It speaks of the gentle, relentless forces that have shaped our solar system over eons. It is a reminder that the clockwork motions of the planets are not perfect, but bear the scars and stories of a violent and dynamic past. Venus, the planet of beauty, moves to its own slow, inverted rhythm, a solitary waltzer in the grand ballroom of the sun, forever turning backward against the flow, a serene and silent testament to the quiet, enduring forces that guide the heavens. Jupiter's great red spot is a storm lasting 400 years. Let us turn our minds to the king of the planets, the gas giant Jupiter. A world of swirling, banded clouds, a canvas of creams and ochres painted by tempests of unimaginable scale. And at the heart of this majestic chaos, there spins a solitary, enduring marvel, the Great Red Spot. It is not a mountain, nor a continent, but a storm, a vast, swirling vortex of clouds that has been churning for at least 400 years, and likely much, much longer. Imagine a tempest so large that our entire planet Earth could be swallowed within its crimson embrace, with room to spare. It is an anti-cyclone, a high-pressure storm where winds scream at speeds exceeding 400 miles per hour, racing around a center of profound and ancient calm. To witness it from space is to see a colossal, slow-motion whirlpool in the atmosphere of a giant, a great, bloodshot eye staring out from the deep. Its longevity is its most soothing mystery. Storms on our world last for days, perhaps a week, yet this one has persisted through centuries. It witnessed the invention of the telescope, the birth of modern science, and the dawn of the space age. It has weathered the chaotic flows of Jupiter's atmosphere, a stable island in a raging, fluid sea. It endures because it is caught between two powerful opposing jet streams that keep it spinning, a self-sustaining system on a scale we can scarcely comprehend. And yet, even this titan is not eternal. Over the past century of observation, the great red spot has been slowly, gracefully shrinking. It is a gentle reminder that even the most permanent-looking features in the cosmos are part of a cycle of change, a dance of formation and dissipation that operates on a timeline far beyond our own. There is a profound peace in contemplating this ancient storm. It is a lullaby of persistence. It reminds us that the universe operates on scales of both time and space that can humble and calm the human spirit. The great red spot is a silent, swirling witness to the passage of ages, a steady, rhythmic breath in the atmosphere of a giant, inviting us to let our own worries be dwarfed by its enduring, majestic presence. It is the storm that never ends, a perpetual, soothing whirlpool in the clouds of a distant world. Some galaxies collide slowly over billions of years. Let us contemplate one of the most majestic and serene ballets in the cosmos, the slow, inevitable dance of colliding galaxies. This is not a violent, explosive crash, as the word collision might suggest. It is a patient, graceful intertwining, a merging that unfolds over timescales so vast they defy human imagination. A billion years, then another, and another. Imagine two spiral galaxies, each a vast island of hundreds of billions of stars, drawn together by their mutual, gentle gravity. As they first approach, their immense gravitational fields begin to whisper to one another across the light years. These whispers are the first touch, pulling delicate streams of stars and gas from their outer edges, stretching each galaxy into long, luminous tidal tails that arc across the darkness like celestial bridges. Then the true dance begins. They do not smash together. Instead, they pass through one another, their stars sailing like tiny, distant ships on a dark ocean. The spaces between stars are so incomprehensibly vast that direct stellar impacts are extraordinarily rare. The galaxies swing past each other, their momentum carrying them apart, but their gravitational embrace pulls them back. They swing again and again, each pass drawing them closer, their structures becoming more and more distorted. The beautiful, ordered spiral arms are stirred into chaotic, beautiful plumes and ripples. Throughout this eons-long waltz, the real drama occurs not with the stars, but within the vast clouds of gas and dust. These cosmic nebulae are compressed, jostled, and stirred, triggering a brilliant fireworks display of new star birth. The galaxies blaze with the light of millions of newborn stars, glowing in vibrant pinks and blues. A final, glorious burst of creation before the dance concludes. Finally, after billions of years, their separate identities fade. They settle into a single new galaxy, most often a featureless, serene, elliptical galaxy. The dynamic spirals are gone, replaced by a calm, ancient swarm of stars, a testament to the union that came before. This cosmic merger is the ultimate lullaby of deep time. It reminds us that the universe operates on a timescale of infinite patience. What we might perceive as a cataclysm is, from a galactic perspective, a slow, stately, and inevitable reunion. It is a process not of destruction, but of transformation. A gentle, gravitational embrace that forges a new whole from two separate beings, all in a silence so profound and over a duration so long, it invites the soul to a state of deepest, most tranquil peace. Cosmic voids stretch across hundreds of millions of light years. Let us turn our minds away from the brilliant tapestry of galaxies and stars and toward the true dominant architecture of our universe, the cosmic void. These are not mere empty spaces, but vast hollow regions, immense bubbles in the foam of creation that can stretch for hundreds of millions of light years. To contemplate one is to gaze into the deepest quiet the cosmos has to offer. Imagine a sphere of space so enormous that our entire Milky Way galaxy would be but a tiny, insignificant speck within it. And within this sphere there is almost nothing. A handful of isolated, lonely galaxies may drift like forgotten ships in an ocean of night, but for the most part, there is only a profound and perfect blackness. The vibrant galactic superclusters we often marvel at are merely the bright, thin walls and filaments that surround these all-encompassing voids. The existence of these voids is a direct and soothing consequence of the Big Bang. In the earliest moments of the universe, tiny quantum fluctuations were stretched to cosmic proportions by a period of rapid inflation. Where the primordial soup of matter and energy was slightly denser, gravity pulled more material in, eventually forming galaxies and clusters. And where it was slightly less dense, matter slowly drained away, leaving behind these ever-growing expanses of near emptiness. The void is not a place where nothing ever was. It is a place from which nearly everything has gently departed. There is a profound and humbling peace in this concept. The glittering galaxies we see are not the main feature of the universe. They are the decoration on the edges of a much vaster, much emptier structure. The cosmos is not a uniformly scattered collection of lights, but a great cosmic web, and the voids are the immense, dark rooms in that web's architecture. To think of a cosmic void is to listen to the universe's deepest lullaby. It is the sound of space itself, expanding in perfect silence. It is a reminder that emptiness is not a void in the sense of absence, but a fundamental component of existence. Within these vast, dark regions, the potential for future worlds and galaxies is diminished, but the sheer scale of the quiet inspires a different kind of awe. It is the universe's breath held in the pause between thoughts, a serene and majestic nothingness that gives the sparkling galaxies their meaning simply by being their silent, boundless counterpart. Pulsars emit regular signals like cosmic lighthouses. In the vast, silent ocean of space, there exists a phenomenon of perfect, predictable rhythm, the pulsar. Born from the dramatic death of a massive star in a supernova, what remains is not silence, but a cosmic metronome of incredible precision. This remnant, a city-sized sphere of ultra-dense neutron star, spins at a breathtaking rate, and in its rapid rotation, it becomes a lighthouse on a galactic scale. Imagine a star so compressed that a single teaspoon of its material would weigh 1 billion tons. Now, imagine this incredibly dense object spinning hundreds of times every second. As it spins, it channels powerful beams of radiation from its magnetic poles. If one of these beams sweeps across the path of the Earth, our telescopes detect it as a pulse of energy, a flash of radio waves, X-rays, or gamma rays that arrives with a regularity more dependable than the most accurate atomic clock we can build. This is the pulse of the pulsar. A flash, a pause, a flash, a pause, repeating for millennia with unwavering consistency. The timing of these pulses is so exact that astronomers can predict their arrival for centuries into the future. It is a rhythm set in motion by the laws of physics during the star's collapse, a spin that will gradually, imperceptibly slow over eons, but for now provides a steady celestial heartbeat. There is a profound and soothing comfort in this cosmic clockwork. In a universe that often seems chaotic and unpredictable, the pulsar is a testament to underlying order. Its reliable, rhythmic signal is a lullaby of physics, a gentle, repeating note in the darkness that reminds us of the fundamental laws that govern everything, from the fall of a leaf to the spin of a star. It is the universe's way of keeping a gentle, silent time, a beacon not of random noise, but of perfect, peaceful rhythm, pulsing steadily across the light years. Certain stars die in spectacular supernovae, explosions. Let us contemplate one of the universe's most profound and beautiful transitions, the death of a star. Not all stars fade quietly. The most massive among them, those true giants of the cosmos, meet their end in a final, magnificent act of creation, a supernova. For millions of years, such a star has served as a cosmic furnace, forging heavier and heavier elements in its core through the relentless power of nuclear fusion. It builds layer upon layer like a celestial onion until its heart is filled with iron. And here, the star reaches a silent internal crisis. Iron is ash. It cannot be fused to release more energy. The furnace at the star's core sputters and goes out. In that instant, the outward push of radiation that has supported the star against its own immense gravity vanishes. The star's core collapses catastrophically, falling inward at a tremendous fraction of the speed of light. In less than a second, what was a core the size of Earth is crushed into an impossibly dense ball of neutrons, a city-sized object with the mass of a sun. The outer layers of the star, now with nothing to support them, come crashing down upon this newly formed, rigid surface. They rebound in a titanic shockwave, a blast of energy so immense that it can, for a few glorious weeks, outshine an entire galaxy of 100 billion stars. This is the supernova, a stellar farewell that scatters the star's enriched guts. The carbon, oxygen, silicon, and gold forged in its heart and in the fire of the explosion across interstellar space. There is a deep and humbling peace in this cosmic cycle. The cataclysm is not merely an end, it is the source of all complexity. The iron in your blood, the calcium in your bones, the oxygen you breathe, all were forged in the heart of a long-dead massive star and seeded into the cosmos by its supernova death. We are, quite literally, stardust, and our very existence is tied to these ancient, spectacular explosions. So, the supernova is a lullaby of rebirth. It is the universe's way of recycling matter on a grand scale, of ensuring that from an ending comes the potential for new beginnings, new stars, new planets, and perhaps new life. It is a brilliant, fleeting flower in the cosmic garden, a reminder that even in an act of immense violence, there is a profound and enduring beauty, a necessary step in the great, slow dance of cosmic evolution.